If you stand at the south rim of the Grand Canyon, just stand there, still, and look out. What you're actually seeing is roughly 277 miles of exposed earth, walls of layered rock descending more than a mile below your feet, colors arranged in horizontal bands of red and tan and pale gray, each one a different geological age stacked on top of the last, like pages in a book someone forgot to close. Most people describe it as overwhelming, humbling, one of those rare places where the human brain simply cannot scale what it's looking at. But here's the thing that almost nobody mentions when they're standing there, the thing the tour guides move past quickly, the thing even the geology pamphlets treat as a footnote. Some of those cliffs, the ones that feel like the most ancient, most permanent structures on Earth, the ones that give you that quiet vertigo, that sense of permanence, those walls are filled, layer by layer, with the preserved remains of ocean creatures, creatures that only ever lived in shallow, warm, marine water. And they didn't wash in from somewhere else. They didn't fall from the sky. They were there, on the seafloor, when those rocks formed. They were buried where they lived. And then, somehow, over a span of time so long it barely means anything to us, they ended up inside what is now the most famous canyon on a continent that doesn't have a sea anywhere near it. That's where this story begins. The Grand Canyon is carved into the Colorado Plateau, a massive, high, dry region in the American Southwest that sits at an average elevation of roughly 5,000 to 6,000 feet above sea level. Geologists will tell you, confidently and correctly, that the canyon itself was carved by the Colorado River over the last 5 to 6 million years, give or take, as the plateau slowly rose and the river cut downward through the rock in response. That part is well understood. It is, in the scientific community, not really in dispute. What is less commonly discussed, or rather, what is discussed among geologists but rarely makes it into the public conversation about this place, is not how the canyon was carved, but what was already in the rock before the river ever started cutting. Because the layers of the Grand Canyon are not simply layers of sediment pressed together by time and pressure. They are specific kinds of sediment with specific kinds of inclusions, pointing very specifically to specific kinds of environments. And when you read those layers carefully, when you follow the logic of what each one contains, a picture begins to emerge that is genuinely difficult to reconcile with the image of a desert landscape that most people associate with the American Southwest. The Redwall limestone, for example, one of the most prominent and recognizable cliff-forming layers in the canyon, sitting roughly halfway down the canyon wall and visible for miles. That formation is packed with fossils, not just any fossils, marine fossils, brachiopods, which are filter-feeding organisms that live on the ocean floor, crinoids, which are sea lilies, animals that anchor themselves to the seafloor on long stalks and fan their feathery arms into the current, corals, bryozoans, sponges. These organisms do not live in rivers. They do not live in lakes, generally. They live in oceans, specifically in shallow, warm, clear marine environments, with a particular chemistry and a particular depth. And the Redwall limestone is not a thin, incidental layer. It is roughly 400 to 500 feet thick in places, 500 feet of marine sediment, compressed and lithified into pale gray limestone, sitting in the middle of a landlocked desert plateau. That is already a strange thing to look at, but it is only the beginning. The Kaibab Formation sits at the very top of the canyon, the uppermost exposed layer, the one you're standing on when you look out from the rim. It is the youngest rock exposed in the sequence, which means it was the last layer deposited before whatever process eventually stopped depositing sediment here and started eroding it instead. And the Kaibab Formation is also marine limestone. So the top of the canyon, the rim itself, the surface under your feet, is fossilized ocean floor. It contains the shells of marine bivalves, sponges, and an organism called a brachiopod that geologists use as what they call a facies fossil. meaning its presence in rock is taken as direct evidence of a specific marine environment. At the bottom of the canyon, near the Vishnu basement rocks, which are among the oldest exposed rocks in North America at nearly 2 billion years old, you are standing at what was once, in one of several ancient ocean periods, also likely a seafloor. The metamorphic and igneous rocks down there are the product of intense heat and pressure at depth, the remnants of a very old, very complex geological history that involves cycles of ocean flooding and mountain building going back to